We already seen lift and chi-square may not be very good measures examining the transaction data that contain lots of null transactions. So what we may like to see is what are good measures. They do not influence much by number of null transactions. Let's look at those different measures. Some measure, they have the property called null invariance. That means their values may not change with the number of null transactions. Okay. Let's see what measures are null invariant, what measures are not null invariant. We already know chi-square and the lift, they are not null invariant. Their value change with number of null transactions. But people have found that the following 5 measures, if you check their formula, their definition, they are actually null invariant measures. So you probably know Jacquard coefficient and cosine measure quite well. These 2 measures are popularly used. They are null invariant. But all confidence, which actually take the smaller value among A and B as the denominator, the numerator is just the transaction support, the support of the rule. So the max confidence is trying to find the maximum one of them. These 2 actually were proposed in the study of measuring association rules. Kruzinski measure was proposed around 2007 by us, by our group. We originally called these as balanced measure, but later the reviewer actually pointed out that this measure was actually proposed by a Polish mathematician called Kruzinski in 1927. So we changed the name of this measure to Kruzinski measure. Let's first look at null invariance, why they are very important. That means why in analysis massive transaction data, the null invariance is so critical. Because in many transactions, the transaction set contain particular sets of items, the chance actually is very rare, like Walmart transactions. They may contain neither milk nor coffee. When you try to analyze milk and coffee using the following contingency table, so this MC means the number of transactions that contain both milk and coffee. This not M not C means the number of transactions that contain neither milk nor coffee. So this not M not C is the number of null transactions. Then we see lift and chi-square, they are not null invariant, so they are not good at evaluating data that contain too many or too few null transactions. For example, we just look at this, okay? For this data set D1, MC means number of transactions that contain both milk and coffee. Not MC means the number of transactions contain no milk but coffee. M not C means the number of transactions that contains milk but not coffee. Not M not C means the number of null transactions that contain neither milk nor coffee. Okay, so you probably go to like a Walmart, this kind of shopping market. You probably see there could be the cases you get 10,000 transactions that contain milk and coffee, but 1,000 contain not milk but coffee, 1,000 contain milk but not coffee. In that case, you probably say, actually, likely if people buy milk, they would buy coffee as well because there are 10,000 such cases. By only one of them, it's only 1,000. But if you have a lot of null transactions, this value could be quite positive. If you have very few null transactions, it turns out they are independent. You probably look at the value, they are not independent. On the other hand, if you see there's only 100 cases you got milk and coffee together, there are many more cases they buy it alone. But once you have many null transactions, it turns out to be very positive. The number is quite big. So no matter you get a very many null transactions or very few null transactions, something may go wrong. Okay. So we do need to analyze such data using some null invariant measures. Okay, we'll examine this in more detail.